Good morning, everybody.
Happy June 1st, first day of June. This is it. 3 more weeks and you have survived. So today's learning objective, we want to be able to determine the length of an arc given the radius and the central angle of a circle. So this is going to take us back to something we learned last week.
Now, notice the difference of the question. It's not asking you the measure in degrees. It's asking you the length, the actual length. If we could take a ruler, but a ruler has a straight edge. A circle here is a rounded edge. So really, we learned about radian last week, which we discussed is the amount of radii that fit around the circle. That's where it comes from. It helps us measure an angle. So remember, we started something like a construction like this. Now, can anyone think about it and tell me how many radians approximately would this arc right here, this angle, I'm sorry, be?
So I would think that would be 2 radians because you made 2 arc marks using the length of the given radius.
So that would be good. An angle of 2 radians. And let's just say this radius is 5 centimeters long. How long in centimeters do you think this arc would be?
So it would be 2 of the length of the radius, which would be 10 centimeters.
That means this little piece is 5 centimeters, and this other piece is another 5. So in total, the whole entire thing, and I agree with Miss Murphy here, the whole thing would be 10 centimeters. So notice it always depends on the number of radians that you have. So I'm going to actually write this out like this. The arc length is equal to the radian, the angle in radian times the length of the radius. So I'm going to write it like this for now, just so that you could see. If I had 2 radians, the length of my arc was 10. So 2 times the radius, which is 5, equals 10. If I had 3 radians, it would be 5, 10, 15 centimeters long. If I had a little bit more, if I had 3 and a bit more, it would be maybe closer to 11 or 12. So notice that this is really like a formula right here. But we don't usually write formulas like this. We use letters to represent them. So you already know the letters for these two right here. If you remember, there is a Greek letter that's commonly used for an angle. Do you remember what that letter is, that Greek letter?
Theta?
Yeah, it was that one that looked like this. It was like a circle with a squiggle. So that's really called theta. So that's what we use for an angle. And then what letter do we use for radius?
R.
So R for radius. And then the only other letter that you're not sure that's new to us is this arc length. Arc length is commonly used with the letter S. So I like to remember this formula, and I'm going to spell it out like this, SOAR.
I'm glad you're spelling it like that kind of sore instead of a sore like a cut. I'd rather soar through geometry than wind up feeling sore for having learned it.
That is funny. So S equals theta R. Now, again, a big key part here is that the angle has to be in radians because that's what talks about the length, how many radii fit around the circle.
Okay, so it sounds to me like you're foreshadowing a little bit, Mrs. Talhami, that you're telling us it has to be in radians. So we really have to be careful to look and make sure that the angle we're given is not in degrees.
Mm-hmm.
Because if it is, we're going to have to do a kickback to last week and maybe do a little conversion to make sure we keep it in radians.
Absolutely. And I'm just going to be one more specific word that I missed is that just make sure it's the central angle that they give you. So that's what I just wrote up here. Make sure it's that central angle of the circle, because sometimes they could trick you and give you an inscribed angle, which would not be accurate. You have to use the central, where the vertex is in the center.
Very good. Well, the first example is nice for us then, because I do see a radius of 5, so r equals 5, and I do see a central angle of pi over 3. And so if we were going to find the arc length S, we could just use our SOAR formula.
Is there a way that we can approximate what our answer should be before we even do this?
Well, it seems to me that we only have one length, one radian of, now you're looking at that and I'm looking at the radius of 5, and I'm thinking since we only have one radian that it should be about 5 centimeters.
How do you know we only have one radian? What do we need to... See, you're telling me this is 1 radian. Did you do the math already, Miss Murphy? Did you jump ahead and do that math?
I did not.
Did you... Well, if you do pi divided by 3, what do you get?
Oh, so pi divided by 3, I'm going to put that on my calculator, is 1.04.
Okay, so since the angle, which is what you were just... I think you did it by looks then, right?
I did.
Okay, so let's make sure we're not assuming. We got to make sure for a fact, because they can, not draw it to scale, right?
Yes.
So, but you ended up being correct anyway. We kind of just figured out that pi over 3 radians is about 1.04. So if it's about 1 radian, then maybe we should only fit about 1 radius. So this length should be close to what number for 1 radius?
5.
It should be close to 5, so let's plug in what we know. So we don't know the arc length, and then the angle is already in radian as pi over 3, and then the radius is 5. Now, if I wanted the exact answer, what did we say about plugging in pi?
So if we multiply pi over 3 times 5, that's really 5 pi over 3. So 5 pi is 15.707 divided by 3 equals 5.2359. It's an irrational number, so it's approximately 5.23.
Sure, I'll just put 5.2.
5.2. So look how close that is to the radius of 5.
So the math kind of made sense here. This is how we could check ourselves. We knew that the angle was about 1 radian, so only 1 radius would fit. So it had to be around 5, which when we did the approximate answer, we got 5.2 centimeters. If I ask for an exact answer, 5 pi over 3 centimeters would also be acceptable. So either one of these answers. So I know Miss Murphy likes us to box our answers. So here's the exact answer up here, and here's the approximate answer. That's why I have that squiggle. All right, let's try one more example.
Okay, so this is just like the one we did. So let's do that thought process that Mrs. Talhami just showed us. And what is pi? So let's put pi in our calculator, divided by 2. It tells us that we should have 1.57, so about 1.5 radians. So if 1 radius is 16, half of 16 is 8, and 16 plus 8 is 24. So I'm guessing that it's going to be approximately 24 centimeters, Mrs. Talhami.
So let's see what she just did. Make sure you focus. She said the angle is about 1.5. So 1 plus half of the radius. So 16 plus half more, which is 8. She said somewhere around 24, which I loved how you did that, Miss Murphy. That was some wonderful work.
Thank you.
So pi over 2 times 16 equals 16 pi over 2, but that can be reduced
To 8 pi.
8 pi centimeters.
Which is 25.13.
Isn't that up to what your approximate was about? You said about 24. So yeah, it makes sense, 25. So do you guys see how radian measure can help us find the length of the arc? We're going to do one more example. Are you ready?
So just to be clear, Mrs. Talhami, before we go on.
Sure.
Basically, if a student was to cut that green part of the arc, the part of the circle off, and were to straighten it out so it was a line,
Yes.
that line would be approximately 25.13 centimeters.
Correct.
Okay. So that's what we're doing, just to make sure that you understand.
Yeah. I think we're going to just do one more
So
example.
now, they don't give us a picture, but they give us great words, and we can actually draw our own picture if we needed. Little trick here I'm seeing already, Mrs. Talhami. I'm seeing degrees, not radians. But we're not going to worry about that because you taught us that we can convert radians in degrees into radians by using the formula pi over 180 equals radian over degree. So if we kept pi over 180, we're trying to figure out the radian, so we can make radian x over the degree is 30. Let's cross multiply. So we'll have 30 pi equals 180x. So we're going to divide both sides by 180. So we should get 1 pi over 60. Pi over 60. Right? 3 times 6 is 18.
You mean 6, not 60?
1. Yep, 6. Oh, what did I just say?
60.
Yep, 6. Sorry, that's what I meant. Okay, so we do have a radian measure now, pi over 6. Let's go and soar. All right, so to find the arc length, we're going to take the central radian of pi over 6 times the radius of 3. They give us that in the question. So we have 3 pi over 6. I always just like to reduce it, so that's 1 pi over 2. Pi over 2, that would be our exact answer.
And that's actually what it's asking for in this problem.
Okay, great. Oh yes, E for exact.
Mm-hmm.
Pi over 2.
And you can always check your work. You can ask yourself. Now, there's 2 ways you could check your work. You could tell yourself that 30 degrees is approximately how much of a radian. Now, does anyone remember how many degrees is about 1 radian? If you remember, 1 radian was about 60 degrees. So if 1 radian is 60 degrees, then we need half of that radian to be 30 degrees. So we would need half of that radius, right? So half of 3 is how much?
1.5.
Good. So now if I do pi divided by 2 in my calculator, I get 1.57. So it looks like we kind of did it right here. So yeah, look, there are 2 other problems that you have to convert. Right here and right here. But then if you look
just like we did for number 1.
But if you look at number 4, do we have to convert here?
Yay, we do not. It already gives it to us in radian.
Wonderful.
Mrs. Talhami, I think you have the charger.
Yeah, I know. I'll charge it while we're recording.
I almost thought that popped up on mine.
No, that's right. I closed it out. So here's what I'm going to do. I'm going to pause the video, and I'm going to ask that you guys complete these remaining practice problems.
This.
Oh, no. Hold on one second. My iTunes opened because I plugged it in. Say that one more time. Soar through this.
you want them to soar through these activities. Really try to practice. The more you write out formulas, the more they'll stick with you. Yeah. Remember, it's not just about now. Some of you will be taking SATs in the future for college entrance exams. You want to know things like these geometry tips.
Absolutely. All right, so we'll see you in a bit. All right, so we actually completed the remaining examples. I'm going to zoom in so you can see all the work. Make sure you convert, if they give it to you in degrees, to radian, and then you could soar. And please excuse any background noise you guys hear. Remember, we're still teaching from home, so it might be the TV in the background.
Pause as needed. Notice how our fractions are getting reduced. Leaving them as exact answers. The bottom three were nice because none of them needed to be converted. We were given the radians and we could just immediately soar. By the way, that's my favorite ride at Disney. Soar.
Oh, yeah?
Yeah. It's absolutely incredible. It takes you around the world in 10 minutes.
Oh, wow.
Yeah.
I think I know which one you're talking about.
So for those of you out there who haven't done that ride yet, you can Google it.
I haven't been to Disney in a very long time.
Disney's just starting to open back up.
Oh, that's very nice. So there you go. I went through them pretty slowly so that you could pause it and check your work. But that's really why we learned radian to begin with. Notice how just because we knew what radian was and, that it was a measure of that angle, we were easily able to determine the length of those arcs. If you have any questions, make sure you reach out to myself or Miss Murphy. And I hope you guys have a great day.
Follow up with your 5 Castle learning. See you Wednesday. Bye.
Bye.